loud and clear? Guys, can you please confirm the voice is loud and clear? Yeah, guys, can you confirm now how it is clear? Now? Yeah, guys, can you please confirm me now? It is clear now? Yes. Voice is also clear or it is low? It is clear, right? Done. Fine, guys. So let's start the session. Done. So in the last class, yeah. So in the last class, we are discussing about the artificial intelligence, that is deep learning. In that deep learning, we are discussing about the neural networks, how the neural network works, right? Now, in today's class, we are going to continue the same with the neural networks, and let us see how it is going to work. Okay, so let's start this. So in the neural network, already I have told you, there is neurons, input neurons, hidden layer, and output layer. It's like that. Next month, 15th నుంచి కంటిన్యూ Okay, so now here we are having with respect to the neurons, and we have discussed about the input layer, hidden layer, and output layer, and how many number of neurons should be considered in the input and output and hidden layers that we have discussed. Now in today's class, we are going to understand how these neural networks, means what these neurons will do and how these neural networks will learn and how they are going to work. In the last class, we have discussed about the design of the neural network. In the last class, I have completed the design of neural network, how to design the neural network. Now, if you remember this design of neural network, we are having in terms of input layer, which is nothing but number of input variables equal to number of input variables which are going to be in the extrain data. And we are going to have the hidden layer and followed by output layer. If the output layer is in terms of you are having the output layer regression or binary classification, you are going to consider one neuron. Otherwise, you are going to consider the multiple neurons. Okay. Now, if just I'm showing you the coding part. Okay. I'm not going to explain the coding part, just to have an idea only. I'm going to show you. Okay. Now, clearly we'll discuss in the separately. Okay. Now let me show you the coding part. In the coding also, first what we have to do is first we have to design. The neural networks design and this one is entirely different. Now, what is the difference between the machine learning versus deep learning coding part? Let us see. Okay. Now here I'm going to take the artificial neural networks. In the artificial neural networks, for example, okay, so artificial neural networks, where here I'm having with respect to data set called as temperature, pressure, humidity, and vacuum. And based on that, I have to expect the energy. That is the output variable. Where my output variable is a continuous variable, it is a regression project. Basically, it is a regression project where my output variable is energy. And the energy is dependent based on the temperature, pressure, humidity, and the vacuum levels. Now here I'm having a data set like this, and I'm going to drop the output variable. The entire data cleaning. So first, whatever the first business problem understanding, no difference. First, you have to understand your business problem. What is this business problem? What is the output variable, and everything you have to understand, and what you have to work. Common. That is common in the ML, and that is common in the DL or AI. Both of them, it is common, no difference. And whether it is NLP also, same. Business problem understanding, whether this is, let us write like this, whether it is ML, NLP, and deep learning. In these three of them, business problem understanding, whatever the first step is the business problem understanding, in three of them, it is common, no difference. First step, you have to understand what is the project about. Commonly, you have to understand. Next, data understanding. That is also common in everything. Whatever we have done in the machine learning, the same logic is applied, right? No difference. Now, third one, we are going to do the EDA in the machine learning. That is structured data. If you are having any structured data, then where we are applying the machine learning, there we are going to apply the basic one, EDA. EDA followed by data cleaning, followed by data wrangling. In the data cleaning, missing values is compulsory. In the data wrangling, encoding is compulsory. Otherwise, model will not fit. It will throw the error. Similarly, in the deep learning, when you are using the ANN, the common, it is also common. EDA you are going to do. Why you are going to do the EDA? Because in ANN also we are going to apply the same structured data. Same pandas, same loading the data, same Excel file, CSV file, everything is same. So EDA is common, data cleaning is common, data wrangling is common. After that, you are going to apply the train test split here. And the same thing you are going to apply here also, train test split. Up to here, there is no difference as it is. In the first, let us compare between this instead of NLP. First, let us compare the ML and DL. Later, we'll compare with the NLP. Okay. Now, in this, you are going to do this one. After doing this one, what you are going to do here? Modeling. In the modeling, what you are going to do? You are going to import the ML algorithm. You are going to save into a model name, and you are going to fit on X train, Y train. Here, the modeling is slightly different. The modeling is like, this is the main important part. The modeling will be different. And after that, here you are going to do the evaluation. What is meant by evaluation? Evaluation means you are going to check with respect to if it is a regression project, you are going to check with respect to RMSE. If it is a regression project, or R square. If it is a classification project, you are going to see the accuracy, confusion matrix, classification report, precision, recall, F1 score, like this. These are the evaluation metrics. Now, same to same, no difference in the evaluation. Same RMSE, same logic, no difference in the evaluation. After that, what you are going to do here? Model selection. Model selection means you are going to check whether your model is overfitted or underfitted. At the same time, you are going to check your test accuracy is equal to CV score. Same thing, no difference. Sir, same thing. You are saying same thing means then what is the difference, sir? Only difference is modeling. Only difference is modeling. Here modeling of ML is dead easy. How it is dead easy means just you have to import the algorithm and save into a model name and fit on X train, Y train. That is called as modeling. But here the modeling is different. After the modeling, prediction, model.predict on X train, model.predict on X test. That is common. That is not a different. Prediction is common, evaluation is common, and followed by model selection is common, hyperparameter tuning is common, grid set CV is common, everything is common, but only the difference in the modeling. Now here, I'm having a data set like this. Okay, I'm having a data set like this. That is with respect to the energy data, where I'm having the input variables X1 I'm having the input variables x1, x2, x3, x4, and y. Output variable y. Now what I'm going to do, I'm going to load the data. After loading the data, I'm going to separate the x. Here there is no encoding is required. Since I don't require encoding, so missing values are not there. So directly I'm going to take the x is equal to drop the output variable, and in the output variable I'm considering the output variable directly. So x and y. After that, what I'm going to do, train test split. I'm going to apply the train test split. After train test split, now in the original data, how many records are there? Overall, 9,568 records are there. 9,568 records with 5 columns. Now, 9,568 records where I'm taking the test size of 0.2. So, 9,568 into 0.8. 0.8, that is 7,654 records. 7,654 are used for training purpose, and the remaining 9,568 into 0.2, which is nothing but 1914. 1914 records are used for testing purpose. Overall data is 9,568 records. Okay, so these many records are used for testing purpose, and these many records are used for the training purpose. Now, if I open my data, 7,654 records are used for the training purpose. Up to here, it is common, no difference. Now, let us see how we are going to apply the same logic in ML. ML means we are going to import that one, and we are going to save and fit on the X train, Y train, and we are going to predict, and we are going to calculate the R square. Now here, ANN, how we are going to do the ANN? ANN will be done in terms of by using the Keras. So Keras dot model import sequential, that is the first step. Okay, and Keras dot layers import the dense. This is the second one. You are going to use the library called as Keras. Now here I'm going to use this. Just observe this one, whatever the code I'm going to write. Here, I'm going to take model. Model is equal to sequential. What is meant by sequential means whatever the order I'm going to write, that is the order which you have to consider. That is the meaning of that. So model is equal to sequential, and model dot, this is the first step, model dot sequential. Okay, model dot sequential. Sequential means first step. Whatever the order I'm going to write, that is the order you have to consider. Model dot add. Add means I'm going to add. What I'm going to add? Input dimensions is equal to 4. Input dimensions is equal to 4 means input layer is equal to 4. So initially it is going to take 4 values like this. Once it is completed, now I'm going to add units is equal to 1 means I'm going to take immediately 1. So 4 and 1. And next, what I'm going to do, dense. Here there is a word called as dense. Dense means connection. And kernel initializer is equal to uniform. Uniform means it is going to take 4 weights. It is going to select the 4 weights between -1/4 to +1/√4. It is going to take 4 weights between this randomly. Randomly, it is going to select 4 weights from this data, which forms the uniform distribution. That is -1/2 to +1/2. So 2 weights, it is going like this, it is going to consider. What are the 2 values randomly means? -2.4, -0.25, -0.1. These are the 2 values, plus 1.15, plus 3.9. These are the 2 values. Total 4 values. So -0.25, -0.1, 0.15, and 0.39. It is going to consider like this. This is the meaning of this particular line. Okay. Here I have written total with respect to, just observe once again this line. Model dot add. Model means sequential. Sequential means whatever the order I'm going to write, you have to take in that order. What I'm going to add means first step I'm going to add. Add with respect to dense. Dense means connections. These lines are there now. These 4 lines are called as dense. Input dimension is equal to 4. 4 means this is the input layer where it consists of 4 number of neurons. Units is equal to 1 means along with your input layer, dense you are writing now. Dense means other side also should be one more neuron. Then only it will be connected. Without you are writing the second layer, how it will be connected? So it is going to connect this one. So it is going to take this one. Now after taking this one, you have stopped the code. For example, you have written like this and you have stopped the code. Now this is the code for the perceptron model. This is the code for the perceptron. You have stopped here. Now, sir, for example, let us take like this. One more example. I want to create like this. This is the neural network. Input layer should be 4. First hidden layer should be 6. Second layer should be 6, followed by output layer. Now, what the code I have to write? Just observe clearly. I'm writing. Model is equal to sequential. Common. First line is common. Sequential means whatever the order I'm going to write, you have to take in that order. Model dot add. I'm going to add. What I'm going to add? First, input. Input is equal to 4. And units is equal to 6. So first it is going to take 4 neurons and 6 neurons. It will take empty neurons like this. Now I'm going to add the word called as dense. Dense means connection. Now it is going to give the connection like this. That is total 24 connections it is going to give. Once it gives the 24 connections, for the 24 weights it has to assign. I'm going to write the kernel initializer is equal to uniform. With this, first input layer and first hidden layer completed. Now, for that, what I'm going to do? I'm going to add the next one. Up to here, it is clear, guys. Now I'm going to add model dot add. Already, what you have added? Input you have added. Input layer, the hidden layer, first hidden layer also you have added. Now what you are going to add? Dense of. No need to write input. Directly you have to write the units is equal to 6 and kernel initializer is equal to uniform. Now what is the meaning of this one? Already you have added from here to here. This part is completed. Now you are going to take this one. Only these 6 units you are going to consider, and these 6 units you are going to give the connections. Means from here to here you are going to do. This is the line. Is that clear? This line is clear. Once again. So here just observe. First I'm going to do the sequential. Sequential means whatever the order I'm going to write. First I'm writing 4. This is the starting. 4. Okay, add means first I'm going to add first initially 4. For example, 1 plus 2 plus 3 plus 9. Like this are there. First, what you are going to consider? 1. For 1, you are going to add the number 2 you are going to add. Number 2 you are going to add. Similarly, here also I'm going to take 4 and 6. First 4 neurons, again 6 neurons. First these 2 will be selected. For this one, it is going to add the dense. It is going to add the dense. Dense means connections. And it is going to give the uniform distribution, total 24 weights. And already this is connected. To which one it is connected? Already these 2 total is already there with you. Now for this total, you have to add the next number. You are not saying, you are not taking separately. You are not taking separately. Already whatever the added one is there, for that total, you are going to add the next number. Similarly, here this is already a model. For this model, existing model, you are going to add the number of units is equal to 6. Got the point? Is that clear now? Now you are going to add the number of units is equal to 6. And these 6, you have to give the connections. These 6, whatever you have selected, these 6 has to be connected to the existing one. Connect means dense you have to take. Now, last, what was left out? This one was left out. Now I'm going to take model dot add. I'm going to add. This time how many units I have to add? 1 unit I have to add. Units is equal to 1. and this will be selected. And for this one, I have to connect to the old one now. How to connect? Dense. And kernel initializer is equal to uniform. Uniform means it is going to take the uniform distribution. Like this. Now 4, 6, 6, and 1. Sir, for example, if I add model dot add and if I take the units is equal to 2 for this, in a flow I have it written like that, then automatically it will be connected with 2 more units like this. It is going to take the dense of 2 more units. Now output is this one. Whatever the last one is there, that is the output layer. If you leave here, this is your output layer. If you leave here, now if you don't connect this one, then automatically output layer is this one only. Whatever is in the last, that is the output layer. Okay, so you're going to add one by one like this, and model dot add of dense with respect to units is equal to 1. You are going to write like this. So in this way, the model initially you have to design as per your requirements. First you have to design. After designing, now you have to fit on the X-train, Y-train. Now when you fit on X-train, Y-train, the data will be passed into this. Whatever the first record data is there, the first record data will be passed into this, and it will do the calculations, and finally it will give the output. Second record will be passed, again output. Third record will be passed, output. Fourth record, output. Fifth record, output. Like this, for every record, it is going to take the output. And overall complete data, whatever the 7,658 records are there, na? Total, I mean, 7,654 records, which are used for the training purpose. All the records will be sent one by one. And finally, it is going to calculate the sigma y minus y hat whole square. And after calculating that one, now it will come back and it will adjust the weights. How many times it will move forward, how many times it will come backwards, sir? Like that, how many times it will come backward? Either you have to get the error is equal to 0, either that one. If error you are not able to get up to 0, then if you have written that one, I want to do this process for 100 times, it will do for 100. If you have written for 50 minutes, it will do for 50 times. Each one is called as epoch. Here it is called as epoch. What is meant by epoch means calculating one by one and passing till this one. And after that, it is going to recalculate and coming here, it is called as epoch. Okay. So now see here, if this is my requirement, now just observe. First, I have taken the model and I have taken the input layer along with the first hidden layer. Both of them I have added at a time and followed by 6 neurons, followed by 1 neuron. This is called as design. These 4 lines of code is called as designing the neural network. Now designing of neural network was completed. Now I'm going to write the compile. Compile means what it has to calculate. It has to calculate the mean square error. Every time it has to calculate the mean square error. After calculating the mean square error, it has to gradually reduce. The error percentage gradually should be reduced. That is gradient descent. That we are going to see this one. So my ultimate loss is mean square error. And now I'm going to fit on the X-train, Y-train. Is that clear, guys? Now let us take a simple example, and for calculation purpose, I'm going to show you this one. So here what happens, model is equal to sequential, model dot add input dimensions is equal to 4 and units is equal to 1. Units is equal to 1 means 1 unit. And dense means you are going to take like this. Okay, this is the model. Now 4 values it is going to select randomly, minus 0.5, minus 0.1, plus 0.15, plus 0.4, something it has selected like this. Assume. Sir, it is going to take randomly. Why you have selected these 4 values means randomly. You have to take the values randomly, but the 4 of them should form the uniform distribution. These 4 weights should form the uniform distribution. That is important. What is meant by uniform distribution means from minus 0.5 to 0, how many you are considering? From 0 to 0.5 also you have to consider the same. So two of them I am considering from here. So two of them I am considering from here. Now it is forming the normal distribution. If you are having any doubt, means take these four values and apply the dot skewness. NP dot array of four values, and for that NP dot array, whatever the array is there, apply the skewness value. You can check the skewness, and if you want, you can see the density curve also. It will be normal distribution in terms of uniform distribution. It is going to be a uniform distribution. Okay. Now, okay, sir, uniform distribution, fine. Initial data, okay. Now what happens? Now what happens? Design is completed now. Assume this is a simple design. Now, once the design is completed, now what it is going to do means here, this neuron is going to collect the information from here, from here, from here, from here. Four informations it is collecting. This particular neuron collecting four informations. It's collecting four informations. Now these four informations it has to process. Now here in every neuron, whatever the neuron is there, every neuron, first it is going to collect the information. So the neuron is going to collect the information, and this neuron collects the information, first collects information, and after collecting the information, it is going to do the processing. And after the processing, it is going to give the output. Every neuron will do the same. Each and every neuron will do the same. Which neuron? Hidden layer neuron and output neuron. Not with respect to input neuron. Input neuron will pass the information only. It will not do anything. It will only just pass. Information it is going to pass. Input neuron will not do anything. For example, your ears are there. As of now, you are listening now. Your ears, the starting first neuron will be there, right? In your ears to brain, in between multiple neurons are there in your body, inside the body. First neuron, which is in the ear starting, first neuron, that neuron will only take the information, and that neuron is sending that information one by one to the brain. You are a very fast learner. Your processing speed is very fast. You are a slow learner. Your processing speed is slow. Some people can't able to understand what we are saying. Okay, for example, in this class, few students, they don't know anything. Okay, still if you explain also, they'll not understand that much of easily. Now, why that is the problem? Because they are not having any previous information. Now, this is next level of information. Now, inside that neuron processing, what is the processing it has to do? If any data is in the sequential order, one by one data is there in the sequential order, automatically it will process the information. For example, you have done first class, completed first class, completed second class. Directly you have jumped to the fourth class without studying the third class. Are you going to face the difficulty or not initially? Later you may settle, that is secondary. But initial first day class or second day's class, what happens? Initially you will face the trouble. Why? Why trouble? Along with you, fourth class students only are there now. You are also one of the student. They are also one of the student. Why you are facing the trouble? Why they are not facing the trouble? Means they have studied in between third class. You have not studied that one. You have skipped that one. Now, the students who has already studied the linear regression and logistic regression, and they have remembered the logics and what are the things we have completed there. Now they'll understand today's deep learning class. Whoever has missed or whoever has forgot or whoever has not practiced the linear regression and logistic regression, for them today is completely like some kind of Japanese movie only. They'll not understand anything, but simply they'll shake their head. Yes, sir. Yes. Action, only action will be there. Kamal Hassan action only will be there. Nothing will be there. Right? Because they don't know anything now. They don't know anything. I also know that one. But Kamal Hassan will come into picture. Acting only will be there. Okay, but internally, nothing will be there. Because nothing is processing now. They don't know anything. So automatically, it is skipped for them. Now, you go to any movie, any thriller movie, after skipping of 1 hour movie. What happens? Though you will not understand anything also, still you see like this only. For 2 hours, you will see like this only. You know, we know that you are not able to understand. But what you will do, you will watch like that only for 2 hours. You will try to connect, but no connections will be there. Thrill movies, if it is a family drama or something like Telugu movies means okay, that is okay. Even second half also we can understand. But if it is like a interstellar movie, if we watch complete movie also only, we don't understand. If that for that movie, if you go for after 1 hour, nothing, right? So here the point is important. Which point is important means the sequential point is important, means the how the processing it is going to do the neurons processing. So here input, I'm writing clearly, input neuron will collect information only. It will collect information only. Or in simple words, input neuron will send the input. It will send the input. It will pass the input. The input neurons will simply pass the input. They'll pass forward. They'll forward the input data. They'll pass the input data. That's it. That is the use of input neuron. Nothing else that it will do. Now, hidden layer neuron. Hidden layer neuron or output neuron. These both of them, hidden layer neuron and also and output neuron. These both of them will do commonly. They will collect the information. They will collect the information. Okay, they will collect the information and they will process the information. They will do the processing and they will do the give the output. They will collect the information. Okay, so clearly I am writing. Than this, still more clearly I will write. They will collect information from the connected input neurons. Whichever is connected, from there only it will connect. It will take. It will not take with the unconnected one. Second hidden layer neuron was not collected directly to the input layer. Output layer is not directly connected to the input layer if you are having in between hidden layers. Whichever are connected, whichever are having the arrow marks, whichever are having commonly this one, whichever connected, this will be sending the information to this one and it will do the process. Here one more neuron is there, means what is the use? It is not going to send the information directly to this one. Whichever are connected only, they are only having that one. So it is going to collect the informations from the connected input neurons. After collecting the information, it is going to do the processing inside the neuron. The processing will be done inside the neuron. Processing will be done inside the neuron. Once the processing is completed, it will give the output. It will give the output. Like this, every neuron will do. Hidden layer will be do and the output layer also will do the same as this. Now the question is, what processing will be done? Now, before seeing the processing, what I have told you, first step, collect the information. Before collecting the information, first input layer will be there. Now, what input layer will do? Let us see. Let us observe what input layer will do first. Okay. What exactly this input layer will do? Let us understand. So here, for example, I'm having a data like this. This is the data. Now, what input layer will do means, here, whatever the data you are having, whatever the data is there, what is the first record? First record. This is the first record. I'm writing the first record here separately. That is 11.2, 11.22, 1017.24, 80.9, 43.13. These are the 4 values. Now, what is this input layer will do? What is this input layer will do means, it will send this 11.22 1017.24, 809, and 43.13. This information will be sent inside. The first record information will be sent inside. That is the input layer. It will send that information. One record is completed a second record. Second record completed a third record. Third record completed a fourth record. For loop. It will apply the for loop. One record after one record, one record after one record. Whatever is in the temperature data, that will be sent into the first neuron. Whatever related to second column, that will be sent into the second neuron. Whatever is in the third column, that will be sent into the third neuron. Whatever is there in the fourth column, that will be sent into the fourth neuron in the same way. Here, it is not going to select. For example, sir, here I am having the data. This 54 will be sent to what? Fourth neuron only. It will not send into the first neuron. Fourth column data will be sent into the fourth neuron. First column data will be sent into the first neuron. That is the order it is going to send. Now, after sending the information, okay, it has sent the information. Now, this neuron, whatever the neuron is there, this neuron, it has collected the information from here, from here, from here, from here. These four informations it has collected. Four values it has collected. And along these four values, four weights also will be there. For these connections are there, means four weights will be there. Four weights and four values. Four weights are there, four values are there. Both of them are there. So now it is going to this neuron, single neuron. I am speaking about only this single neuron. What is this single neuron will do means it is going to collect four values. It is going to collect the four values, the four X values, and along with the four weight values, whatever is connected to this neuron, corresponding weights. It is not going to select the other weights, only the selected, whichever the connections are there, only those weights it is going to select. And these four weights and four X values, now it is going to collect the information. After collecting the information, now it is going to do the processing. What is the processing means? W1x1 plus W2x2 plus W3x3 plus W4x4. It is going to do this one only. Sigma Wi xi plus B bias, some intercept value. Now, so it is going to calculate this one. Okay, calculation completed. After calculation, now here we are having different types of activation functions. Different types of activation functions. Activation functions. Now here activation functions, I am going to give this one as ReLU. Now what is meant by ReLU? ReLU. RE caps lock LU. ReLU. Now what is meant by ReLU? ReLU means RE stands for rectifier. L stands for linear. U stands for unit. This is the full form. Here full form is not important for us. Concept. What is this ReLU will do? ReLU, what it will do means rectifier. Rectifier means first it will calculate the entire value, that is sigma Wi plus B. After calculating this one, now if it is a negative value, the total, whatever the total is there, that is sigma Wi plus B, this value. If this value, total value, if it is negative, the output of this neuron is going to be 0. It will give us 0. All the negative values will be rectified to 0. So if it is not negative, sigma Wi plus B is a positive value. Whatever the positive value is there, it is going to send that positive value outside. This is called as processing. Now here, once again. So collecting, what is the meaning of collecting means? Collecting weights and collecting X values. This is called as collecting. What is meant by processing? Processing means calculating the sigma Wi xi plus B. This is called as processing. Now finally, output. What is the output it is going to give? Based on the activation function. Based on activation function. Based on activation function, it gives the output. Let us assume this sigma wxi plus b is equal to some, name it as z. Create one variable called as z. Z is equal to sigma wxi plus b. Based on the activation function. Here, two activation functions are there. First activation function is called as ReLU. Whenever the z value is less than 0, the output is equal to 0 from that particular neuron. If the z value is greater than 0, the output is z value only. What are the z values there? That is the output. For example, you are having one more activation function. What is that activation function? Is sigmoid. Sigmoid. Sigmoid means here you are going to convert this value. Whatever the z value is there, this z value, after calculating this one, it is going to calculate 1 divided by 1 plus e to the power of minus z, and it is going to calculate the p value. And if the p value is greater than 0.5, the output is going to be 1. If the p value is less than 0.5, the output is going to be 0. Is that clear? This is meaning of a neuron. Every neuron will work like this. Every neuron will collect the weights and every neuron will take the values, and based on that it is going to work. Is that clear, guys? Now, sir, what activation function I have to select? Okay, which activation function I have to select? Simple. Answer is very simple. The activation function which you have to select is for hidden layers. Input layer, anyways, we are not going to do that one. This, all the things will be done only for the hidden layers and output layer. For hidden layers, it is blindly ReLU. Fix. Blindly ReLU. And for output layer, we are going to have, if it is a regression project, for regression project, ReLU. For binary classification project, sigmoid. For multi-class classification project, it is softmax. What is meant by softmax? I'll explain. Just I'm saying that how the neurons will work. Okay. What are the different activation? So many things are there. One by one we'll understand. So simply to say here, what every neuron will do is, it will collect the information. It will do the sigma wi xi plus b inside. And from that, it is going to send the activation function. It is going to have some activation function. And from that activation function, it is going to give the output. Okay. Now, let us take here this neuron. This neuron is there. Now, this neuron, it is going to take the information here, 11.22. And what are the values? Okay. So let me have the first simple example where I'm having input layer and output layer on. Only input layer and output layer. That is perceptron model. First, let us complete this one, and later I will explain that. Now here X1 is 11.22, 1017.24, 80.90, 43.13. First record. Now weight is minus 0.4, minus 0.25, plus 1.5, plus 0.3. Now here, this is the output layer, directly output layer only. There is no hidden layer. It is output layer. Now what it is going to do? First, sigma Wixi plus B. So here W value is there, X value is there. It is going to choose randomly the B value also. B value, W values, both are chosen randomly. And later it will be modified. Now, so here it is going to calculate that one, that is sigma Wixi plus B. So now it is calculating. Let us assume this is calculated like this. First 11.22 into minus 0.4. Let us calculate. Open the calculator. Minus 0.4 into 11.22. That is minus 4. This is total is minus 4.488. Similarly, minus 0.25 into 1017.24, and which is nothing but minus 254.31. Okay, next 80.9 into 0.15, which is nothing but 12.135. Okay, next. Okay, next. It is going to take next in terms of 43.13 into 0.3. That is 12.939. Now, let us take this sigma Wixi plus B. Sigma Wixi plus B means what is the meaning of this? You have to add everything. That is minus 4.488 plus, not plus, minus 254.31. Okay, minus plus 12.135 plus 12.939. It is going to take minus 233. Sigma Wixi is equal to minus 233.68. For example, let us take some B value of plus 100. Okay, some B value plus 100. Every time it is fixed. Plus 100. B value of plus 100. And it is going to take plus 100 for this, and the answer is minus 133.6. First step calculation is completed. Now, since it is a regression project, for the regression project, output layer should consist of what activation function I have told you? ReLU. So since it is a ReLU activation function, what is meant by ReLU activation function meaning is, if it is total value of sigma Wixi plus B, that is Z value, what are the Z value? If it is negative, what is the output? 0. It is going to give the output 0. First record output is 0. What is the original value? Original value is Y train. Y train is the original value. Predicted answer is 0. Second record, predicted answer like this. It is going to take. Now, after that, sir, you may observe, sir, here in this pressure is the highest value. Now, for everything automatically you'll get 0, 0, 0, 0, 0 only. Now, mostly total will be 0 and total will be negative. Total is negative means automatically answer is going to be 0 for every record. Then what it is going to do? It will calculate the sigma W that is Y minus Y hat whole square. It is going to calculate this one. Original value minus predicted value. Predicted value is 0. Original value is there. Whole square it is going to do. Overall, it is going to do the sum. A very big number it will get. Total will be very big number. Now what it is going to go, and it will rectify that one, and it will modify this negative value to the positive value. Due to this one, everything it is converting to 0. So this will be converted to positive value, and later it will do the modification. It will adjust the weights in such a way that finally the ultimate of this one will be low. Got the point? First step itself will not be completed. Again, it will come back. It will come back and it will modify the values. Right? Now, in this way, it is going to process. Now, okay, sir, same information, take like this, 4 neurons. Now you are having with respect to in hidden layer of 5 neurons and one output layer. Output layer is regression problem, so ReLU fixed. For hidden layer, you already told that every time we have to consider automatical layer only. It is also fixed. Now activation functions are ready. Now here, earlier you have taken the same data, na? Whatever the data you have considered, that is your extrain data, that is 11.22, 1017.24, 80.9, 43.13. And it is going to select randomly 4 weights. Okay. And here it is going to connect. After connection, now it will give some output. What is that output it is going to give? First time, what is the output? It is going to be 0. Now this 0 is equal to input value, and this 0 will be multiplied with this weight. And now for in this neuron, how it is going to calculate? The output of this neuron into weight. Similarly, the output of this neuron, whatever the output of this neuron into the weight of this one. Similarly, first it will calculate for this one. For this neuron also one output will be there. Na? The output of this one into this weight, and for similarly this one, the output of this neuron into this weight, and finally this one, the output of this one to the weight of this one. So now it is going to calculate. Now 5 weights are there. What are the input now? Input means not this one is input. Now these are the input. These are the X values. Whatever the output of these neurons you are going to get, those are the X values. Those are X values, and these are the W, and it is going to do sigma Wi Xi plus B once again the same. It is clear now? It is clear? This point is clear? Now second time, when for the second time sigma Wi plus B, X is not the original data. X is input, whatever the output of the first hidden layer is there, that is the X. Is that clear? So here, whatever you are having here, in this case, for this one, for this image, in this here, whatever you are having this neuron, whatever the neuron you are having here, this neuron X1, X2, X3 and X4, and corresponding weights it is going to multiply. Now here this neuron is there. Na? This neuron, how it is going to select means the output of this one, output of first neuron, output of the second neuron, output of the third neuron, output of the fourth neuron, output of the fifth neuron, output of the sixth neuron is considered as X values, and the weights are considered, and it is going to multiply those. And for this neuron, how it is going to work means these are the 6 weights, and along with the output of this one, output. These outputs are considered as the input, and along with the weights, it is going to calculate the output. For this neuron, this is the input. For this neuron, this is the input. For this one, this is the input. Okay. For this calculation, if this is the output means for this is the input. If this is the output means this is the input. If this is the output means this is the input. Like this, the information is getting passed one by one. Is that clear now? How the neural network works? So here it is going to take in this way. Now you can understand the PPT very easily. Okay. So now here, first step, you have to do the sigma Wi Xi plus B. From that, you have to do the activation function. Okay. In my case, the B value I have taken as 0. It is not mandatory that it has to be 0. In this here, I have taken the B as 0. That is the reason you are not able to see the B, but B will also be considered. Activation function is given by like this. This is the notation which I am following. Okay, which I am following. So in different textbooks, the notation might be different, but concept is same. And once now here I'm having a data like this. Now we are having different types of functions. Sigmoid function is available. Sigmoid function means what is the sigmoid function? What are the sigma Wxi plus B is there? That you have to consider 1 divided by 1 plus e to the power of minus y. Now here first you are going to calculate by this value. From that you are going to convert to the sigma Wxi plus B. In logistic regression, we have done the same thing now, right? Now, once you calculated the equation, now you are going to calculate the sigmoid. If the activation function is sigmoid, means you have to do like this. If the activation function is not sigmoid, means just you are going to focus only on the sigma wxi plus b value. You are not going to convert that one. When you are going to convert, or whether you have to convert or whether you have to not to convert, means that depends on the activation function. What is the activation function? Okay. Now, what are the different types of activation functions we are having? See here. In this case, 3 neurons are there. 3 neurons sigma wxi plus b, and later it is converted to an activation function of sigmoid, and it is going to give the output. This logic will be applied in the binary classification, in the output layer of binary classification. So, for example, you are having, this is the input layer, and this is the output layer. Output layer will be only 1 neuron. And in the output layer, output should be either 0 or output should be either 1. It can't give as per your choice the value. For example, you have selected the ReLU as, now you have got here y is equal to 144. What is the output of this one? If it is ReLU, what is the output? 144, you will get the output. 144 can be the binary classification. Is that possible? No, right? In the binary classification, either 0 should be there or either 1 should be there. We can't take as per your choice. So either 0 it has to take or 1 it has to take. So how it is going to work, that one means first it has to be converted to the probability. Is that clear? Now, since here I'm having my, just now you observe again the coding part. Here I have taken the 4 and 6, in between them ReLU. ReLU means I have given the ReLU as the activation function. Here it has to work with respect to ReLU. And here second 6, here also it is going to work with ReLU. Now finally the output, the final output is 1, where activation function, once again it is ReLU. Why it is ReLU in the output also, miss? Because it is a regression project. Now let us see one more project called as classification. Now where I'm having with respect to the output variable, the output variable is whether the person will churn the company or not, whether the person will exit the company or not. It is called as churn modeling. Churn means whether the person will leave the company or not. HR analytics project. Okay. Now here I'm having with respect to the output variable is binary class. Now what is going to change? Only in the coding part, just observe. First I have taken the input dimensions is equal to 11. The number of input variables are 11. So I have taken 11. Followed by 10 hidden layer neurons. First hidden layer of 10 with a activation function of ReLU. Hidden layer activation function should be ReLU. Second hidden layer, again 10 neurons with activation function of ReLU. And the last output layer of 1, because it is a binary classification, only 1 neuron you have to consider, and activation function should be sigmoid. That is the only difference. Remaining everything is same. Kernel initializer is same. Input dimensions, it depend on the number of, everything is same. Only the output changes. Output activation function is sigmoid. Is that clear, guys? Coding part, now it is clear. In the model, in the modeling. Before to modeling, what are the data pre-processing is there? That is common. No difference. If outliers are available, treating the outliers, missing values are there, treating the missing values. If you are having with respect to data has to be done, modified means encoding. Everything is common. Data pre-processing, nothing change. Is that clear, guys? Got the point? Online students, his point is clear. So in the output layer, you are going to select the sigmoid as the activation function. Yes. Now this y minus y hat, how it is going to consider that we'll see. I'm showing you the designing. Now activation functions. We are having the different types of activation functions. What are the different types of activation functions we are having, miss? First type of activation function is called as threshold function, or it is also called as step function. This is first type of activation function. What it will do? Let me write clearly here. Step function. in the notes you write this one, step function. Step function means first it is going to calculate sigma wi xi plus b. Up to here it is common. Okay. If whatever this activation function in the step, what happens means if z value is less than or equal to 0, the output is going to be 0. If the z value is greater than 0, the output is going to be simply 1. This is called as step function. Okay. Now, if you take a graph where this is sigma wi xi plus b, that is z value. If you take the z value, now what happens? Z value, if you are having the negative z value also, now what if you are having the this is the output, y column is the output, and input is z, that is sigma wi xi plus b. For example, z is negative, this value is negative, output is going to be 0. The output is 0, means this is the point. If z value is minus 400, this is 0. All the z values of negative is going to be 0. Now, if this value is positive, for example, you are having the positive value of assume 100. 100 is the positive value which you have got. Now, for that, what is the output? Is going to be 1. For 150, what is the output? Again 1. For 200, 1. For 300, 1. All the positive values, only 1. For all the positive values, 1. For all the negative values, it is 0. Now, for 0, anyways, 0 only. If you consider as negative value also, if you consider positive value also, 0. So this is the diagram. Then left side negative values are going to be 0. Right side values are going to be 1. Is that clear, guys? Clear? This is first activation function. Now, second activation function. Second one, next one. Okay. Now, ReLU. Z is equal to sigma wi xi plus b. Calculate the same. ReLU. Okay. If Z is less than or equal to 0, the output is 0. If Z value is greater than 0, the output is Z value. What are the Z values there? Here output is equal to 1. Here the output is equal to Z. For negative values, no difference. Only for the positive value, instead of considering 1, they have considered the original value as it is. Now take a graph sheet once again, same to same way. Now Z value, whatever the Z value you take here. For example, some Z value, minus 400. You have got minus 400. For minus 400, what is the answer? 0. This is the answer. Fix. For minus 300, 0. This is the answer. For minus 200, 0. For minus 100, 0. For 0, it is 0. So for left side, everything is common as it is. Whatever the diagram you are having, left side diagram, same. Now, positive. If you have got right side plus 1, what is the output? 1. Y also will be 1. If x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. X is 4, y is 4. This total value is 500, means y also 500. So you are going to have a graph like this, linear line, straight line you are going to have. This is the graph of the layer. This is the graph of the step function. This is the graph of the rail. You don't write like this. Multiple times you don't draw like that. Only one time. I'm showing like this. I'm drawing like this, means you don't draw like this. Okay. Don't draw like that. And in the interview, they'll ask you 100% the diagram of the ReLU function also. That is that much of important. So left side values will be with respect to straight like this. Right side value is going to be straight line like this. Okay. Is that clear? Left side, everything will be neutralized to 0. Right side, whatever the value is there, that is the output. In just you take sigma wixi plus b, take one value of your choice. You take 1. Y also will be 1. 1 comma 1, keep 1.1 comma 1. 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. Attach the line. Simple. Here also same. First you take 1. For 1, what is the output? 1 only. For 2, what is the output? 2 only. For 3, what is the output? 1 only. 2 comma 1, 3 comma 1, 4 comma 1, 5 comma 1. For 1 comma 1. So attach all the 5 points. Here also you attach all the 5 points. Take any 5 values of your choice and attach the line. Simple. Whichever the 5 values you want, you take. Take any 5 values and attach the line. You will get easily the graph. Is the point is clear? Now, that is step function and ReLU function. Now, third one is called as leaky ReLU. Leaky ReLU. Third activation function is called as leaky ReLU. Now, what is this leaky ReLU means? First, you are going to calculate the x is sigma wxi plus b. Up to here, there is no difference. If z value less than or equal to 0, in that case, what you have to do means the output should be multiplied with the whatever the z into 10 to the power of minus 5. Whatever the z value is there, it should be multiplied with the 10 to the power of minus 5. Sir, 10 to the power of minus 5 means almost negligible now. Yes, we want negligible. Why, sir? Why negligible? One of the student has got the doubt like this. What is the doubt he has got is in terms of, sir, in the hidden layer, ReLU you are taking. ReLU, the output of the ReLU can be 0. If it is negative means 0, it is going to be. 0 into next one, it is not having anything value now. Means indirectly the neuron has dead. There is no use of that neuron now. The neuron is giving the output as 0. 0 into next weight, whatever the weight is there, total is going to be 0 only now. So what is the use of this neuron then? Whichever the information has given the neuron, right? What is the use of that neuron? There is no use. That neuron is not having any use because that neuron is sending the information 0 as the information. 0 information is not having anything, nothing. So there is no use. So the neurons are dead, equal to dead neurons. So one of the student has asked like this, sir, the neurons are dead now, then what is the use of connecting? So immediately one of the scientists has invented this one called as leaky ReLU. He wants that value, since negative value should not be used at the same time, neuron should not be dead. Right? Means, for example, if you want to kill your enemy, there is one enemy for you and you want to kill him. Don't directly kill him. If you directly kill him, it is called as murder. And it will be booked as a murder case. Don't kill him directly. Kill his brain. If the brain is not there, there is no use of the body. If the brain is not there is no use of the body. Now there is no murder case. For killing the brain, there is no murder case as per Indian law. That is one of the loophole. Lawyer will say like this. If you want to kill means, don't kill directly, kill his brain, remove the brain. Automatically, without brain, nothing will happen. Your enemy will die, but not physical. Okay, here also, there is no use of that neuron, but neuron will be present. Indirectly, you are making as a dummy neuron. Okay, now if you are having with respect to z as greater than 0, output you consider as z only. So what happens here, the graph, the right side part will be as is the curve. There is no difference in the curve of the right side because right side values both are same. Here and here side both are same now. So right side part will be the same. In the left side, what happened? Earlier you have considered as 0. Now you are multiplying with that one. So you are going to have with respect to slightly like this. Some gap will be there. Very negligible values will be there. Very negligible values. Now, one more person has got the doubt after the invention. after the invention, one more student has got the doubt. What is that doubt he has got is, sir, these neurons are not having any use now. They're dummy. They're, instead of killing them, we are making as dummy. Okay. Now using the dummy neurons, overall the data is going to be overfitted, right? More complexity increases, more number of neurons means, and it is going to lead to the overfitting problem. So they identified Ricci-Relu is first they have invented. After invention, they identified this one is having the overfitting problem, and they have rejected this one. Invention was done, rejection also done. Now, which is the best? They have identified means this is the best one. Sir, how it is best one, sir? It is making zero now. Now there is no information now. Which it is making zero, negative values it is making zero. Making of negative values zero is a positive one. It is identifying the which is the worst variable, it is identifying which is the worst weight, or it is identifying the dummy variables, dummy things. That is a positive one. It is identifying the which is the not good one. So this is Relu is the best out of all of them. It will reduce the overfitting problem also. Whereas it will lead to the overfitting, it will reduce the overfitting. So that is the reason everyone has fixed that hidden layer should have the Relu as the activation function. Okay. Is that clear, guys? Now, along with these three, still we are having the activation functions. These three are clear, right? Can I erase completely? Done. Now, the fourth activation function is called as sigmoid. In the sigmoid, what it is going to happen means first Z is equal to sigma Wi xi plus b. Up to here, you are going to calculate same. After calculating this one, you are going to calculate a p value also. That is 1 divided by 1 plus e to the power of minus z. Now, what is the output you are going to give from the sigmoid means p value is the output. The output of the sigmoid is p value. It is going to give the p value. Now you select anything of your choice. For example, you got here negative. Negative also, it is going to give with respect to all the negative values also, you are going to have the sigmoid like this. Though the value of negative also, the finally the probability will be between 0 to 1 only, right? The probability is not going to cross for more than 1. Why? Because it is e to the power of z divided by 1 plus e to the power of z. When compared to numerator, denominator is always high. Whatever the value consider in the numerator, denominator is high. Denominator never it will cross with respect to more than 1. So obviously the sigmoid function, the range of sigmoid is being as the 0 to 1. It is going to be between 0 to 1. So now can output variable can be negative? The output can be negative. Though in value is sigma Wixi plus b is negative. But output p value can be negative? No, p value cannot be negative. Though the value of you have given this one also, the p value is going to be only the positive. P value cannot have the negative. Down part is not there. Down part will be not be having the down part. Only will have the upper part. Like this only will have the upper part. Though you are having the positive values of sigma Wxi plus b also, the p value will be between 0 to 1. If it is this one also 0 to 1. Anything it is going to be 0 to 1. This is the curve of the sigmoid. Next activation function is called as tan. So now here from this, if the p value here directly, the output of this one is going to be the p value. So simply it is going to send the p value as the outside. The neuron will send the output as p. Sir, here it is sending the p means in the output layer also it will send the p value only, na? Yes, in the output also it will send the p value only. In the output layer also it will send the p value only. So here, if you see in the coding, sir, in the coding you have taken the sigmoid as the activation function in the output. Then output will be the, what output will be? Probability. Now this probability after completing, now you have to take wherever the value is greater than or equal to 0.5, it should be converted as 1. You have to write the threshold value after that one. So by default, it will give the output as probability. The probability should be converted to greater than 0.5. If you don't write this one, by default, probability is the output. Sigmoid will give always probability as the output. Is that clear? Now, so output is there. Sigmoid output is there. That is between 0 to 1. All the values are between 0 to 1. Never it will cross the more than 1. And that too, the probability should be positive only. Negative also not possible. Okay. Now the last activation function, tan h. Fifth activation function is called as tan h. Oh, not fifth one. Sixth one also is the softmax. So fifth activation function is called as tan h. Now what this tan h activation function will do? First, it will calculate the sigma wxi plus p. If you observe in all of them, calculation of z is common. There is no difference in the calculation. After that, now here, it is going to calculate the value it is going to calculate in terms of in the tan h activation function. It is going to calculate this minus 1 minus. It is going to calculate 1 minus e to the power of minus 2z divided by 1 plus e to the power of minus 2z. It is going to calculate like this. When it is calculating this one, now as for the z value and the output is going to be between minus 1 to plus 1. Earlier you have got only 0 to 1. The output, entire output is 0 to 1. But this time the output is going to be between minus 1 to plus 1. If you substitute different z values, you'll get the minus also. Some of the values will be minus also. So this is called as tan h function. In the tan h function, you are going to have with respect to 1 minus e to the power of minus 2z divided by 1 plus e to the power of minus 2z, where z is this one. Z is this one. Is that clear, guys? And you are going to have the values between minus 1 to plus 1. In between minus 1 to plus 1. Okay. Now, last one. Coming to the last one, that is softmax. Softmax means z is equal to sigma wxi plus p. This is common. Now, when you are going to use this softmax means when you are having the multi-class classification project. Assume in the output variable, you are having the 3 categories are there. In the output variable, you are having 3 categories, multi-class. Now in the output, you are going to consider the 3 different neurons like this in the output layer. Now what you are going to do means sigma wxi plus b in everything it is going to do along with the p value. It is going to apply the sigmoid only. Again, it is going to apply the sigmoid, that is 1 plus 1 minus e to the power of minus z. And from everything, it is going to get the p value as the output. From every neuron, it will get the p value as the output. P. From everything. 3 of them, it will get the p as the output. And whichever the p is highest, which probability is highest, it will select that class. In this case, it is going to work in this way. Whichever the probability is highest out of these 3 of them, it is going to select that one. Okay, that one as the class, and it will fix that one. In this one, here you are having only one, and it is going to give the probability here. But this probability you are going to take with the threshold value more than 0.5 as class 1, p value less than 0.5 as class 0. But whereas here, whichever the p is the highest, that one you are going to consider. Is that clear, guys? Now, finally, the last one. For this, there is no graph because 3 of them are there. Now, 2 are there means I can represent in the scatter plot. For 3, from where we can represent. Right? For each of them, it is going to calculate the probability from each of them. And finally, it is going to calculate with respect to whichever is the highest. Now, first, if you take the step function, this is the first activation function called as step. Step function, or also called as threshold function, where range. What is the range of this one? Range is either 0 or 1. This is the range. Step function range is either 0 or 1. Next one is what? Next one we have discussed, ReLU. For ReLU function, tell me what is the range, guys? Anyone? 0 to Z. 0 is included? Yes. Z is included? Yes. 0 to Z. This is the range. 0 to Z. Z value can be what? Z value can be? Z value can be with respect to infinite, that is pos to infinity. So the range is going to be 0 to infinite. This is the range. It can't take the negative values. Now coming to the leaky ReLU. For leaky ReLU, what is the range? Range is minus infinite to plus infinity. Minus also, minus, though it is a negligible value, which value we can't know now. So since we don't know anything, so we are writing infinite. So minus infinite to plus infinity. Next, sigmoid. For sigmoid, what is the range? It is 0 to 1. Whether 0 is included? No. 1 is included? No. That is also not possible. In the sigmoid function, never you will get 1 because numerator and denominator never both will be equal. Never it will be equal. So 1 is not possible. 0 also not possible. Right? E to the power of Z cannot be 0. E to the power of Z should be 0 means E to the power of infinite should be there. Then only it is going to be 0. Infinite values will not be there. Right? So sigmoid is going to be 0 to 1. Next, tan H. Tan H function. What is the range of tan H means? This is minus 1 to plus 1. And last one is softmax. For softmax, what is the range means? It is also going to give the probability only now. So 0 to 1. These are the ranges of all the activation functions. Is that clear, guys? So in the tomorrow's class, we are going to learn with respect to for every neuron, how it is going to work and what is the output it is going to give. We have observed. Now, tomorrow we are going to see how it is going to calculate, and after that, how it is going to update the weights. Later, how it is going to modify the weights. Initial weights are something and it is going to modify now. How it is going to modify, how it is calculating the new weight, that we'll see in the tomorrow's class. And we'll complete the activation neural networks in the tomorrow's class. Is that clear? And the most important part is nodes. Here, I'm going to change the drive. Okay, everyone, please take a note of this and just please check. Just open your drive in your classroom. Just open your classroom. In the classroom, whatever the present drive you are having, this is the present drive. Okay, this is the present drive. And this drive link, I'm going to modify. Means the old drive link, I'm going to delete. And I'm going to upload the new drive. In that drive, the entire data is going to be there. For the today's class, tomorrow's class, and entire batch data is there. Okay. Just I'm going to upload the drive just in 5 minutes. Just you can check in 5 minutes. And you can see here the drive will be changed. Instead of the time of 6:30, you'll have with respect to SRK's nodes. You'll have the heading as SRK nodes. Okay, 6 p.m. word will not be there. This word will not be there. SRK nodes will be there. If you open that one, you can see all the modules. In the SQL also will be there, Tableau will be there, everything will be there. Okay, including your capstone project, NASCOM questions, everything will be there. And it depends upon your individuality, whether you have to open or not to open. If you are having common sense, miss, generally we should not open that one because we have not completed. What is the use of opening that one? Now itself, if you open, what is the use? No, sir, I'm not having anything. I will open and I will see now itself, miss, as per your ish. That is your choice. That is your choice completely. Right? I'm going to upload the notes. If you open the further classes also, you will only get confused. Instead of getting the confusion, open the previous classes and study once again. If you are having that much of time, is study once again, recollect and revise. Is that clear, guys? Done. Just I'm modifying the notes, right? Yes. Yes, that there is no rule. I have told you yesterday itself, now there is no rule for the number of hidden layers, and there is no rule for the number of hidden layer neurons also. That should be done by using the hyperparameter tuning. What is the max